Hello and welcome back to another Geo Explainer video. Whoop, whoop. And I am Mr. Coolwijk, your geography teacher for today. And today we'll be talking about what influences the temperatures. Because you now know, of course, which climates there are and how they classify themselves. But how come it is cold or warm in certain places? That's what we will find out today. Isn't that right, Frans? Isn't that right, Frans? Yeah, woo! Alright, as you can see, we have walked into the BW or also the desert climate, and I've built some things here. And today we will use those things. But first, let's get some things out of the way. We are talking here about temperature factors. And there are 3 temperature factors that we're going to talk about today. I'll write them down right here. So the first one is latitude. The second one is altitude. And the third one is land-sea division. That doesn't fit. Division. There we go. What they mean, you will find out in this video. So we will go over them. We'll start with latitude. And for that, we walk over here. Frans, there you are. All right. Now, I've made a small map of the world, and as you can see, it has the North and South Pole and this big red line in the middle. And this should, I guess, be America and Europe and Asia. But just use your imagination. Right, Frans? Yeah. All right. So, to make it easier, back in the day, they would use numbers to identify where they would be on the world in lines, in horizontal lines. So, from left to right. And they started in the middle on the red line, and they call this middle the equator. And this would be 0 degrees. Not Celsius, but just degrees. So at 0 degrees, you are on the equator. That's in the middle of the Earth, between the North and South Pole. And as you go up or down, you go to the Northern Hemisphere or the Southern Hemisphere. And all the way at the bottom, for example here, in the South, you have the South Pole, 90 degrees in the Southern Hemisphere. Alright, and of course, in the northern part, you have the same, but not the South Pole, but the North Pole. So you have the North Pole on the 90 degrees in the Northern Hemisphere. For example, the Netherlands, which should be around here, is on 50 degrees northern latitude. So the latitude tells you something about on which height you are compared to the equator, to the pole, on a horizontal line. And then of course if it's northern latitude or southern latitude, depending on where you are compared to the equator. Alright. Now that we know how the latitude works, we can now talk about the temperature factor latitude. But how does latitude influence temperature? For that, we'll look at this little building stuff over here. So the idea is that the sun, most of the time, is somewhere right above the equator. So above this line. Which means that the sun ray, so for example this one sun ray, doesn't have to travel that long through the atmosphere, which is this kind of glass blocks behind. Meaning that the sun ray with all its sun power only has to heat up one block. But the sun of course also shines onto the North Pole or in the Netherlands. But then the sun ray will have to travel a bit more through the atmosphere. And also, when it's on an angle, it also hits the floor on an angle, making the area it has to heat larger. So the same energy used to heat up one block here has to heat up 2 blocks. And even further away from the equator, all the way to the poles, you can see that the sun ray has to travel a lot through the atmosphere. And then also on this angle, it hits the Earth with 3 blocks. So the same energy has to heat up 3 blocks. Okay, now let's repeat that with some signs. So, at the equator, so this is the equator, sun hits Earth directly. Sunlight travels a shorter distance in atmosphere and uses all its energy to heat up a small area. So on the equator, the sun hits the Earth directly, and the sunlight travels a shorter distance through the atmosphere. As you can see, it's only 1, 2, 3, 4, 5, 6 blocks in this atmosphere blocky case. And it uses all its energy to heat up only this small area. And now as you move away from the equator and the angle of the sun ray on the Earth changes, you can see that on the poles, sun hits the Earth on an angle. Sunlight has to travel a big distance through the atmosphere and uses all its energy to heat up a large area. So the same amount of heat has to now be distributed over a larger area, which of course makes it colder, because then all the heat has to spread out and cover every place. Well, and that makes it colder, and therefore close to the poles it is colder than close to the equator. So when looking at temperature factors, latitude influences temperature, because the further away you are from the equator, the longer the distance is that the sun ray has to travel through the atmosphere, and the bigger the area is it has to heat up. The next of the temperature factors is altitude. It kind of sounds the same as latitude, but it is something different. Altitude means heights. So the higher you go, the temperature will changes. And with higher, I mean literally higher. Think of going onto a mountain. But that's weird, because the higher you go, you should be closer to the sun, right? I mean, the sun is up there, or where's the sun? Somewhere hidden. The sun is hidden. So the higher you go, the colder it gets. So if you go higher and higher, at some point it will get so cold you can see snow on top of the mountains. So the altitude, or hoogte, influences temperature. And how does it do? There is actually a rule for that. The rule goes as follows. Every 100 meters you go up, the temperature goes down by 0.6. So imagine on 200 meters above sea level, it is 10 degrees Celsius. Then on 300 meters above sea level, it cools down 0.6. So it will be 9.4 degrees Celsius. You kind of have to be using some math right here. And of course, if 100 meters is 0.6 degrees down, then 1000 meters up equals minus 6 degrees Celsius. And with this, you can calculate, of course, how cold it is at certain places. And that is how altitude influences the temperature. Isn't that awesome? We now know that latitude, the distance from the equator to the North or South Pole, influences the temperature. And we know that altitude, the height of a place, influences the temperature. So now we only have to know the last one, land-sea division. There's a certain rule with land and seas or oceans on how they influence the temperature. Have you ever noticed that on a nice warm day during summer, you would be chilling on the beach and you would throw your blanket down, ready to play some football on the beach or read a book and chill, and then you're like, I'm gonna swim. And as soon as you get off the blanket, you're like, that's hot, and then you're in the water and like, that is nice and cold, nice and fresh. I mean, the water is still nice and warm, but it is not as warm as the sand. And you swim a little bit and you look into the depths of the ocean and consider going back because that's kind of scary. And then as you get out of the ocean, you're like, ow, ooh, ooh, that's hot, ooh, reach the towel. Nice, I'm safe. That is, of course, because of the land-sea division and the temperature factors. Land warms up quicker than the ocean. So that's the rule. Land-sea division means that land warms up quicker than the sea. But it does not only warm up quicker, because in the evening, when you are walking on the beach, the sand is actually quite cold. Maybe you also experienced this. During the day, the sand was super hot, but in the evening, it's kind of cold. So land also cools down quicker than the sea. So during the day, when the sun is shining, land will warm up and create much warmer temperatures than the ocean. But during the evening or during colder times, the land will also cool down and get colder compared to the sea. So in that way, the land is always a bit extreme, very cold and then very warm, and the ocean is somewhat more mild. It is not that warm during warmer times, but it's also not super cold during cold times, because it doesn't heat up that quick and it doesn't also cool down that quick. But wait, I remember something with the ocean and that it has a temperate effect. That's right, the maritime climate. Because the sea, as close as you are to the sea, because when you are close to the sea, it influences the temperature. So when you are close to the ocean, it has a bigger influence on the temperature around us than you are far away from the ocean. That means that we in the Netherlands have quite a big influence from the ocean. And that people, for example, in Poland or in Russia, far away from the sea, have little influence from the ocean. And this eventually comes back to the maritime and continental climate. Alrighty, I hope you had a great time. I hope, of course, you also learned something new. And I will see you in the next one. Thank you and goodbye.